Alright, welcome to our second video of Unit 7. This one we're going from the plum pudding model to the nuclear model. So, while the plum pudding model was revolutionary, it's also extremely short-lived. It kind of got disproved about 10 years after it came out. In 1907, Ernest Rutherford, a co-worker of Thomson, the guy who, made the plum pudding model, was investigating the plum pudding model by shooting a beam of alpha particles at a sheet of gold foil. I'm really trying to see what happened. I'm not really sure how he got to this point, but he was basically saying, I have a sheet of gold foil, and I shoot a beam of particles at it, and he's seeing where they split off to, if they split off at all. He found that most of the particles deflected about 1 degree. So, not much at all. But just to be thorough, he had his assistant check for wider angles. It was actually in basically a round thing like this, if you will. And he's saying, what's happening back here? Just make sure there's nothing outside that 1 degree angle. Plum pudding model said that all the electrons are in the middle. So if you shoot a array of particles to kick them out, they should all go basically in the same direction, or so he thought. To many people's surprise, particles were actually found at very, very large angles. So we have a gold foil, and he was finding that while most of them went this way, he also had some coming off of this. He was like, that's weird. That's not making sense. And he found that basically the plum pudding model could not explain that, because the plum pudding said the electrons weren't moving, and they should not go in different angles if they're all pushed from the same position. That shows that something was causing the particles to shoot away from the nucleus, even though Thomson, with the plum pudding model, thought the atom was just a dense sphere with positive charge throughout and electrons mixed in. That was the current model, but Rutherford looked at it and realized that current model does not work, does not fit the actual data that I'm seeing. So, Rutherford basically decided to make his own model. In 1907, Rutherford developed the nuclear model, which states that most of the mass of an atom resides in an extremely small dense region called the nucleus. So instead of all the mass being spread out all throughout evenly, he's saying all the mass is basically in one small little area, which today we actually know is quite true. The nucleus, however, comprised very little of the overall volume. So he said, there's the nucleus, but the electrons were scattered outside the nucleus, composing most of the volume. Now, that's not quite exactly how he had. Thing you got to know, most of the mass is here, and electrons are outside. So they're not all in the same blob of chemicalness. He hypothesized, therefore, that if some alpha particles got too close to the nucleus, the positive charge would actually repulse them and shoot them off at weird angles. He basically said that you've got negative and positive charges, and they are actually going to be acting as such, meaning the positives push away the positives, the negative push away the negatives, etc. So, there you go. Alright, finally, we got to draw a picture of what the atom looks like according to the nuclear model. The very common way of looking at it is you've got a nucleus, and then you've got electrons around it. Now, we've not mentioned anything about orbiting, so it's not really correct. That's just what we typically associate with him. Really, all he said is you've got a small thing and electrons are outside of it, taking up a lot of space. So, both are fine. All you need to care is that small, dense mass and electrons are outside of it. There you go. That's the nuclear model.